temperature depends on the time. I hope this helps you guys graph in chemistry or science in general and get all those points on those lab reports. And before some of you skip this video and say, I know how to graph, I learned that in math. I understand that, but I want to show you the details about what you need to do as far as making graphs and interpreting graphs in chemistry. So in chemistry, we're talking about relationships between variables. And I have a table here very much like you would collect in lab. I've got time versus temperature. So as you see, someone measured temperature every 5 seconds and recorded that. So how do we determine the relationship? And you can say, well, I see that temperature increases with time. Is that the relationship? Well, it is, but we can find out a little bit more about the relationship by creating a graph. So first of all, let's talk about the variables. Which one depends on the other? Well, I see that the temperature depends on time. So time is the independent variable and temperature is the dependent variable. Temperature depends on the time. So once we get that established, we know that the independent variable goes on the x-axis and the dependent variable on the y-axis. Now, here we go. Let's talk about graphing. Now, first of all, in math, let me just pause right here. When you graph in math, you often have positive and negative axes, right? We don't do that in science. Generally, time doesn't go backwards. We generally don't have negative numbers. So let's look at this. We make an L, right? And you can do this on the computer, or let me just show you how to graph it by hand. So first of all, we want to label our axes. So our independent variable is time. So we'll put that on the bottom. And then we definitely want to label that with seconds right there. Okay. And then on the y-axis, we want temperature. And we definitely want to put those units in there, degrees C. All right, now we need to create a scale to plot this data. Well, the time is going to go from 0 seconds up into 30 seconds. And I can just eyeball that. I can make a mark at 1/3. That would be 10 seconds, 20 seconds, and then I can mark the 5s. Okay, I created the scale. It's like a little ruler. Now let me go up and do the temperature. Well, I'm going to make it easy on myself. I'm going to start at 37.00. And then let's say this is 38 and 39. And then we'll go to 40. Okay, now how much do I need to mark in between? I'm going to mark my half degree marks. And now I'll plot this graph. Okay, so you can see that I have plotted these points and I want to circle the points. Okay, in chemistry, it's good to circle the data points. All right, so we see that temperature increases with time. Now, we don't draw a straight line through this graph. We want to draw a smooth curve. And I can see that this graph increases like this, and this thing is increasing faster and faster. So look at the relationship here. We see temperature and time in a whole new light when we graph it. Now, the last thing we want to do to make this thing a perfect graph would be a title. Never put a graph in a lab report where you haven't labeled it. So generally, take your y value, your y-axis, whatever that is, temperature, and then we want that versus the x-axis, so I would say time. Okay, and if you can be more specific for reaction 1 or whatever is in your lab, that is a good graph. So make sure you have a scale, make sure you have labels, make sure you have a title. The last point I want to make is this: don't connect the dots. Look at this data. This is volume and pressure. And let me just show you what would happen if I connected the dots. Okay, so does it really go up and down? Well, actually, this data just approximates the straight line relationship. And so I would see that this is a straight line relationship. This is the relationship between volume and pressure. It's a straight line. In fact, we could write an equation for this line. So if you have a straight line relationship, it's fine that the straight line doesn't go through every data point. That's good. the real life data just approximates the true relationship. So I hope this helps you guys graph in chemistry or science in general and get all those points on those lab reports.